Good morning, class. Today we are going to discuss about a topic called matrices. I guess you all are familiar with this word because you did this chapter before in class 10, right? So, today we will see a bit more in detail about this chapter. So, what we will discuss today is what matrix is. We basically know that what matrix is. It's an arrangement of numbers in rows and columns which is placed inside a bracket, right? Then we'll see what are the types of matrices. Then we'll see equality of matrices. We'll come to this. Then we'll see how to find the trace of a matrix. Then we'll see several operations which we will be applying on matrices, problems, numericals. And at last we'll come to see how to find the transpose of a matrix. Okay. So we'll come to our first topic. See, what is it? As I told you, it's a rectangular arrangement of numbers in rows and columns enclosed either in parenthesis or box bracket, right? Why do we use it? We basically use it to solve several mathematical expressions, and this matrix helps us to solve all these expressions easily, right? So to know what is important here is if there are m rows and n columns. See, this is your matrix. You can see here is one row and this is the other one, another row, right? And this way it is column. So here are basically 3 columns and 2 rows, right? You can see it over here. So we name these rows as m and columns as n in the array. The matrix is said to be of the order m into n. So here the number of rows is 2 and the number of column is 3, right? So here the order of the matrix is m into n, that is 2 cross 3. So in this matrix shown below, we can see that all these A11, A12, A13, 21, 22 and 23 are actually the elements of this matrix. Okay, the first one actually denotes you the row number. Okay, this one actually indicates the row number. Okay, and the second number here represents the column number. Okay, so this is A11. This element is placed in row 1 and column 1. Here we see that it is placed in row 1 and column 2. So it's written 1, 2. Similarly, all these elements has been formed. Okay. Coming to our second topic is the types of matrices. We are mostly familiar with this word row matrix, column matrix, square matrix. Okay, what is a row matrix? A matrix which actually contains only numbers in a row and there is no column. See, this is a row matrix actually where m is 1. Why m is 1? Because you can find only one single row. This is the single row. So this matrix is called as row matrix. Similarly, here you find only one single column. Here you can find only one single column, right? So this is known as column matrix. Now coming to the square matrix, what is it? It is a matrix which has equal number of rows and equal number of columns. So here the number of rows is 2 and the number of column is also 2, right? It's 2 and 2 for square matrix. So if the number of rows and the number of columns are same, it is termed as square matrix, be it a 2 cross 2 matrix or 3 cross 3 matrix. Coming to another one is zero matrix. What is a zero matrix? If all the elements inside the matrix is 0, then that matrix is termed as zero matrix. Next is diagonal matrix. What is it? All the elements placed in the diagonal section and rest of the elements are zero. Then we call this matrix as diagonal matrix. You see? Just see this. This total, this diagonal, this is the diagonal of the matrix. Okay? All the elements in the numbered elements are in the diagonal position, and rest of the numbers other than the diagonal one are zero. So this kind of matrix is called as diagonal matrix. Okay, a square matrix with its non-diagonal elements. This means all these elements other than the diagonal elements are zero. This matrix is termed as diagonal matrix. Coming to the next one is the scalar matrix. What is a scalar matrix? It's diagonal matrix whose all elements are zero. It is a diagonal matrix whose all elements are equal. Sorry, all elements are equal. You can see that elements here in the diagonal position are all same, 2, 2, 2, right? And other than the diagonal elements, all other elements are zero. So this kind of matrix is called as scalar matrix. Coming to another one is the unit matrix. What is unit matrix? The diagonal elements of the matrix are equal to unity. Okay, you see it's equal to unity. I mean it's 1. All the elements in the diagonal position is 1. So this kind of matrix is called as unit matrix. It is also called as identity matrix. Remember this, huh? This is very important. It is also known as identity matrix. Okay. Then finally we come to triangular matrix. What is triangular matrix? If every element above or below the diagonal is 0, the matrix is said to be a triangular one. You see, this is your diagonal position. All the numbers, all the elements above this diagonal position is containing number. So this kind of matrix is known as upper triangular matrix. Why? See, it is forming a triangle in the upper side, right? So that's why it is called as upper triangular matrix. And in this case, you see, it's forming a triangle in the lower side. So that's why it is called as lower triangular matrix. Got it? Now we come to another topic, that is equality of matrices. See, if there are two matrices, say A and B, like we can see it over here, A and B, right? So these two matrices will be equal only if the order of these two matrices are same. You see, what is the order of matrix A over here? As I said before, that order of matrix is m into n, right? What is m? M is number of rows. Here it is, number of rows is 2. And number of columns is also 2, isn't it? Right? So I wrote it over here, 2 cross 2. Similarly for B matrix, the order of the matrix is also 2 cross 2. Right? So now the order of both the matrices are same. Therefore, we can equate these two matrices. Now the second one is that all the elements of A are equal as that of the corresponding elements of B. We can say that if the elements of A is same as the elements of B, then we can easily say that these two matrices are equal, right? So these are the two conditions. Now we see in this part, two matrices A, that is Aij, these are the elements, Aij are the elements inside A and Bij are the elements inside B matrix of the same order are said to be equal if Aij is equals to Bij. What we can do is, we will calculate individually, okay? First one is element of A matrix in column 1, in row 1 and column 1. So what is row 1 and column 1? This one, 1. Okay. Row 1, 2 will be 2. Element 1, 2 will be 2, and element 2, 1 will be 3, and element 2, 2 will be 4, right? Same way we will be calculating for this. What is that? What is the element of B for position 1, 1? It's X, then it's Y, then it's Z, and then it's W. Okay. Now we can equate this. Why we can equate this? Because both are 2 cross 2 matrix. So if A and B are equal, so yes, A and B are equal, then we can calculate the values of X, Y, Z, and W. How? We just need to equate this, like A. First one we will calculate A. Sorry, A 1 1 equals to B 1 1. What is A11? A11 is 1, right? And what is B11? B11 is X. Got it? So we got the answer over here is X is equals to 1, right? Similarly, Y will be equals to 2, then Z will be equals to 3, and W will be equals to 4. This is how we get the answer. So one similar problem based on this is, if the following matrices are equal, this A and A, sorry, this should be B, or any other matrix, it shouldn't be A. So if A is this and B is this, you need to find the values of P, Q, R, and T. What will you do? It's simply the same way. You will be calculating it in the same way as the previous one. You got to equate this first element of A with the first element of B. Then the second element of A will be equated to second element of B. Then similarly the third element of A will be equated to the third element of B, and fourth element of A will be equated to fourth element of B. And then this way you will be getting four linear equations, right? And you know how to solve linear equations. You will be substituting whatever values you will getting of P in another equation, and this is how you will get the answer for P, Q, R, and T. Okay. Now come to the next topic. It is trace of matrix. What is trace of matrix? It is the easiest one and the simplest one. You get a matrix, and if you are asked to calculate the trace of that particular matrix, all you got to do is that you just have to add all the elements in the diagonal position. All the elements in the diagonal position. So what is the elements in the diagonal position here in this matrix? It is 1 plus 2 plus 3. So simply we write trace of matrix A is 1 plus 2 plus 3, that is equals to 6. This was a 3 cross 3 matrix. See, the number of rows and the number of columns is 3, and this is 2 cross 2 matrix, right? Here in this case you have 1 and 4 in as the diagonal elements of this matrix. So you simply add those elements and you get the trace of this matrix. Okay. Now we come to the next topic, that is operations on matrices. What are the operations? What we can do with these matrices? We either can add 2 matrices or 3 matrices and so on. Either we can subtract those matrices, or we will be able to multiply those matrices, which we will come after this topic. Firstly, it is addition and subtraction. It is simple one. You know it well. A is equals to this matrix has been given. B is this and C is this. You have been given 3 matrices. You just need to add. You just need to find A plus B is equals to C. You have been given this equation also, and you just need to find the values of X, Y, Z, and W. What you will be doing is you will be just adding all the elements of A and B and will be equating it with matrix C. Okay. Just see this equation, A plus B equals to C. This is how you will be writing the matrix, right? In place of A, you write the matrix A plus you write the matrix B. In place of A, you write matrix A, then plus, then matrix B, then equal to matrix C. All these matrices are given to you. Now you just simply add these two matrices and you equate it with C matrix, right? So what is your first element in A? That's 1. First element is B is also 1. 1 plus 1 will give you 2. And this 2 you will be then ultimately you will be getting one final matrix. Say it's D. Okay. After adding A plus B, you get a matrix that is termed as D. Okay. So then you will be equating this with the C matrix, right? So the first element of D, that is 1 plus 1 is 2. You're gonna equate it with X. You get the value as 2. Similarly, all the other elements you will be adding, you'll be getting all the answers of all the values of X, Y, Z and W. Now what is a scalar multiplication? Scalar multiplication is simply multiplying a given scalar number with the matrix. Okay, to multiply a scalar times, that is a number will be given and you simply need to multiply that number with each elements of the matrix. Okay, so it's given example, if A is this, then find 10A. Now what is 10A? 10 is just a number. You just need to multiply this number with A matrix. So simply you will be multiplying 10 with 2. That gives you 200. Then 10 with 5, that gives you 50. Then 10 with 4, that gives you 40. And then 10 multiplied by 10 gives you 100. Okay. Coming on to the next part is matrix multiplication. Now what is matrix multiplication? We will be multiplying two matrices to get the final matrix. Okay. Now here is a condition which we need to remember while multiplying two matrices. What is it? See this expression. Here M is number of rows for A and P is number of columns for matrix A. And here in B, P is the number of rows and N is the number of columns. And after multiplying, we finally get a result, that is matrix C, whose number of rows is M and number of columns is N. Okay. Now you see the condition, the main condition is, can you see this P? For matrix multiplication, for multiplication of two matrices, the condition is that the number of columns for your first matrix, this is your first matrix, this is your first matrix. So the number of columns for the first matrix should be equal to the number of rows for the second matrix. This is your second matrix. You see here the number of columns is P for first matrix and the number of rows for second matrix is also P. Here in this case, both the number of columns for first matrix and the number of rows for second matrix is same. So only then this multiplication will be possible. So this is to be remembered that P is that the number of columns of the first matrix has to be same to the number of rows for the second matrix. Okay, here is one such example. A is given to you and B is over here. Here the number of rows and number of columns is 2 cross 2 and the number of rows and number of columns for matrix B is 2 cross 3, right? You see here number of columns for matrix A is 2 and number of rows for matrix B is also 2. Therefore, this A into B multiplication will be possible, right? This multiplication will be possible because it has satisfied the condition. So here we do the multiplication. Now, the process of multiplication, how do we do that? You see the first row, here I have indicated the arrow. The first row of matrix A should be taken and put over here. Here, like -1, and here you put it as, what is the second element? It's 2, right? So now simply you will be multiplying this element with all the elements of the matrix B. How do we do that? -1 is firstly multiplied with this first element, that is 0. Okay, so -1 into 0 gives you 0 here. Then we come to the we come downwards. We see here it is 2. So 2 will be multiplied by 3. That 3 2s are 6, gives you 6 over here. Right? And all this will be having a positive sign in between. Unless and until you get a minus or negative sign in the matrices already. Okay. Now what we do for the next element is, again we multiply this -1 with the second element of the second matrix, this one. So -1 into -1 gives you -1, right? Now coming downwards this way, you have 2 over here. 2 will be multiplied with, this 2 will be again multiplied with this number downwards. That is 2 into -1 gives you -2, right? So here we get -2. Fine. Now again we will be doing this calculation. We will be repeating this. Let me clear it so that you can see it clearly. -1 and this was 2. Now we'll multiply this number with this number. So -1 into -2 gives you +2. Here it's +2. Similarly, then you will do 2 into this element, 0. 2 zeros are 0. Gives you 0. Okay. So this completes our first row. Okay. Now we will come to the second row. How to calculate that? Now we will take this row, the second row of the first matrix, this one, 0 and 3, and we will write down it over here in front of the second matrix in vertical way. Okay, column wise. Here you are taking it row wise and here you are putting it in column wise. Now again we'll do the same process. 0 into 0 gives you 0. Then 3 into 3 gives you 9. And you have to put a plus sign in between unless you get any minus sign in the matrix previously. Now similarly we'll do it for the other one. That is, this 0 will be multiplied with 1. That gives you 0. 1 is 0 into 1 is 0. Then this 3 multiplied by -1 gives you -3. Right? Same way, again this 0 gets multiplied by the number -2, which gives you 0. And then 3 gets multiplied with 0, which again gives you 0. So this is how you do the multiplication for two matrices. And then you simply just add all these numbers, calculate these numbers, and here you get the final matrix. This is the result. Got it? Now one thing to be noted here is that here A dot B is not necessarily that A dot B will not be always equal to B dot A in general. I have given a note over here. Matrix multiplication is not commutative in general. That is, A dot B is not equal to B dot A. Why? because the condition has to be satisfied that the number of columns for the first matrix should be equal to the number of rows for the second matrix, right? Okay. Now we come to the next topic, that is properties of matrices. What are the properties of matrices? See, A plus B is equals to B plus A. This is simply addition of two matrices. This is known as commutative law. Then is A plus B plus C is equals to again A plus B plus C. But this here we calculate B plus C together firstly, and in this case, in second case, we calculate A plus B together. That is called as associative law. Then I into A plus B can be splitted into the normal multiplication. How we do is that multiply the scalar quantity with the matrix. So I will be multiplied by A and again I will be multiplied by B. This is called as distributive law. Why? Because we distribute scalar number to both the matrices. Other properties are A bracket of B plus C. This is again similar to the distributive law. We just multiply A with B matrix and again A with C matrix. Okay. Here A plus B, the second one is A plus B into C. Again you just simply multiply C matrix with both A and B matrices. Another one is A into B, C is equals to AB into C. And here comes the previous one which we just learned before, that AB is not equals to BA in general. Then another one is AB equals to 0, not necessarily imply that A equals to 0 or B equals to 0. Why? Because if AB is a matrix and you multiply those two matrices and you get the resultant to be as 0, that is a null matrix. But that necessarily doesn't imply that the matrix A has to be 0 and matrix B has to be 0. We can't consider that those two matrices will be 0. Okay. But after multiplication you are getting it as 0. Then another one is AB equals to AC, not necessarily imply that B equals to C. Now we come to our last topic for today's class, that is transpose of a matrix. What we do here is that the rows will be interchanged to columns and the columns will be interchanged to rows, either way, to get a transpose of a matrix. Okay. Here we can see an example. See, the row 1 of this matrix A is 5, 1, 2. After transposing it, what we do is the row matrix changes to the column matrix, column wise. Row, it's written row wise over here, we will be changing it into column wise. So 5, 1, 2 here gets interchanged to 5, 1, 2 vertically. Here it was horizontally. Okay, here it becomes vertically. Right? Similar way, the second row is 3 minus 1, 4. After interchanging it, we write it this way. So the row changes into column. Okay. Or we can do the alternate one. All the columns will change to row. Here you see it's 5, 3. It's written vertically. We change it to horizontally after interchanging it. Here it's 1 minus 1 vertically. Here it's written horizontally. Here it's 2, 4 vertically. Here we write it horizontally. So this is how we get the transpose of a particular matrix. Okay. Rule is that rows will be changed to columns. Simple. Or the other way, the columns will be changed to rows. Okay. Now there are two new matrices which we will be learning, that is a symmetric matrix and a skew symmetric matrix. What is a symmetric matrix? A symmetric matrix is a matrix that after transposing a particular matrix, we get the matrix to be same as the previous one, as the original matrix, right? Here, if A is equals to A transpose, supposedly we get a matrix, say 2, 1, 1, 2. What we do is we transpose this one. What we will do? We'll write all the elements here in row wise into column wise. So here it is 2 1. We write 2 1 like this, and then we take the second row and write it here in the second column. See, aren't these two matrices same? Right? So therefore we say this kind of matrix to be a symmetric one, to be a symmetric matrix. And the other is skew symmetric matrix, or it is also called as anti-symmetric matrix, right? In this case, after transposing a particular matrix, you actually don't get the original one, but you get a different matrix that is not same to the original matrix. That kind of matrix is called as skew symmetric matrix. Okay. Now here is one important note, that if A is a square matrix, like square matrix is this one, 2 cross 2 matrix, then A plus A transpose, see A plus A transpose here, either way you can write the transpose of matrix can be written in A to the power T or A dash. Okay. So if A is a square matrix, then A plus A transpose is a symmetric matrix, is considered to be symmetric matrix, and A minus A transpose is considered to be a skew symmetric matrix. Hence, every square matrix can be expressed. You can express this kind of matrix as sum of, important one, sum of symmetric and skew symmetric matrix. So here is the relation, that any square matrix can be expressed as a sum of symmetric matrix and skew symmetric matrix. Okay, we come to one such example. See here, one matrix is given, you just transpose this matrix. Okay, how you'll do that? Minus 1 2 here in row gets interchanged into column in this matrix, minus 1 and 2, right? Then here 0 3 in the row section gets changed to 0 3 in the column section. Now we calculate A plus A transpose and we get this result. Now A plus A transpose, as I said, it is known as symmetric matrix, and A minus A transpose will be known as skew symmetric matrix. We just calculate this. We know the operation how to do A plus A, how to do the addition of two matrices and subtraction of two matrices. It's simply just the normal algebraic function. Okay. After calculating A plus A transpose and A minus A transpose, we can write it in this form, this expression which we learned before, that it can be expressed as a sum of skew symmetric and symmetric matrix. So simply what we do is we write this value of A plus A transpose here and A minus A transpose here. Okay, so we expressed a matrix as a sum of symmetric and skew symmetric matrix. So this is for today's class. The rest part which we will be doing will be continued in next class. Okay, hope you all understood it. Thank you so much.